right, so today we are learning your last section. This is a short chapter. Don't you guys like short chapters?
Yes.
Okay, last chapter was long, next chapter is long, but this chapter is short, so we'll enjoy that. Okay, this is special systems of equations. Okay, now you're going to see all of the methods tied into this lesson. What you've done so far this chapter, every system of equations that we've solved so far had one solution. One solution simply means an ordered pair, okay? So now, today, we're going to bring in our special solutions. When would I have no solution, and when would I have infinite solution? Well, you actually have an advantage here with no solution, because in the last chapter, in chapter 13, we learned that parallel lines have, how do their slopes compare to each other? If they are parallel, what will they have? They'll have the same slope. So if I'm looking for the point where lines cross to be the solution, if they're parallel and they're never going to cross, there's no solution. Okay? So there's actually a little shortcut here by evaluating the slope. All right, and you will be allowed to use that shortcut. We'll talk about that in just a second. Then we have infinite solutions. Infinite solutions are actually the same exact line. If you were to graph it on a graph, it's actually going to be the same exact line. All right, so special solutions. When would it be helpful to use graphing? When would it be helpful to use substitution or elimination? So you will have a section on your quiz and test that says pick whatever method you want. Solve it. Now, obviously, we wouldn't just create a graph, but graphing can be helpful if the system is already in slope-intercept. Okay? Substitution could be my method of choice if it's a simple equation where x or y is already solved for. It's already by itself. Elimination could be a good method to use if x or y is easily canceled out. So that's kind of some of the criteria that I'm looking for when I'm trying to figure out which method to use. All right, so what I did here is I gave you some examples of this type of system. I would think, okay, graphing would be a good idea. So on the first one, why would I say graphing is a good idea on this first one?
They're both in slope-intercept.
They're both in slope-intercept. Is that what you guys were thinking? Okay. Yep. The second one, why would I say the second one, substitution is ideal? Okay, x is solved for. My x and my y terms are not lined up on the same side of the equation like I need for elimination. So x is solved for, so substitution. Why would you say elimination for the last one? What is it? Because your 4y's cancel out, and then you can just solve for x. All right? So just kind of picking your preferred method. Okay. So I want you to look at the next example. I am going to show you the shortcut first, but then I'm going to show you how using one of your methods also gets you the same answer. Okay? All right, let's pretend for a minute that we don't know the answer is no solution. Okay? Look at this system here. What information here in this system actually tells me that these two lines are parallel and there will be no solution? What do I see? They have the same what? Slope. Now, you can only say that if the equations are in slope-intercept. Are they? They are. So you can say this is no solution. If you recognize this shortcut, and it is on your homework assignment as well, if you can recognize this shortcut, I will accept this as an answer because it works every time. If you can prove that it has the same slope or different slopes, if it has different slopes, there is a solution, then that tells you the answer. Now, let's just say you kind of blank on the shortcut and you're like, I don't remember what the shortcut is, so I need to solve this system. Okay, we don't have a graph. Let's use substitution. Let's see what kind of answer I get if I take 3x plus 1 and I plug it in for y on the other equation. So I'm just doing substitution here, like I've done before. So now I have 3x plus 1 equals 3x minus 3. Now I see I have x's on both sides of my equation. All right, y'all talk to me. What do I need to do to get x on the same side of the equation? What do I do? Y'all just tell me, talk to me. Subtract 3x. Okay, so I'm trying to move it, but then what happens when I try to subtract it from the other side? It cancels out again. If my x's cancel right now, I know I have a special solution. Bring the rest down. Is it true that 1 equals negative 3? No, it is not. This is no solution. Okay? So you can prove no solution in one of two ways. You can either verify if the lines are parallel by comparing the slope, or you can use one of your methods. All right? Do you guys like having options?
Yes.
All right, so you have an option there. You can do either one. All right, look at the next problem. Can I compare my slopes as the equations are written right here? Can I compare them? Can I say negative 5 and 5 are different, so they're not parallel? Can I say that? No, because it's not in slope-intercept. So you have two choices. You can either write this equation in slope-intercept and then compare them, or you can do substitution. Now, because this is practicing my methods, I'm going to do substitution. Okay? I feel like it's the same amount of work either way. So I'm going to plug in negative 5x minus 2 for y on the second equation. 5x, that was in my original, minus 5x minus 2 equals 0. You see what I did there? I plugged in negative 5x minus 2 in for y. Now I need to simplify. But what do you guys notice that happens here that's a little bit different than what's happened before? What do you guys notice? The 5x's cancel. They're gone. So now what's left?
Negative 2 equals 0.
And that's not true. No solution. No solution. Okay? All right, is everything okay? Everything all right? Example 2. Oh, example 1, number 3. All right, you try this one. You can either use the shortcut, all right, that we talked about, or you can use substitution to solve this. All right, either do the shortcut or use substitution. It's up to you. All right, so what did you do? How did you answer this one if you use the shortcut?
Solution parallel lines.
Okay, parallel lines. Both of my slopes are negative 1. Okay, because they cross the y-axis at different points, I know they're parallel lines. They're not the same line because they cross at different points. So I can say no solution, parallel. Now, if you had plugged it in for y and got negative x plus 3 equals negative x plus 5, you would have seen when you try to add x, they cancel. Does 3 equal 5? No. So it's no solution either way. All right, there's actually a section, it's not going to be on your homework, but there's a section in your textbook that says, without showing any work, tell me if there's one solution, no solution, or infinite. You use the slope. You use the slope. If the slopes are different, there's definitely going to be a solution. If the slopes are the same but different y-intercepts, there's no solution.
So on this, if they have different slopes,
It's one solution, yes. Because think, if it's a different slope, if they're slanting different, at different rates, they're going to cross at some point. All right, so different slopes is one solution. All right, you guys got that? Okay, so now let's look at infinite solutions. What does an equation look like with infinite solutions? So when I look at this system, all right, let's look at the first one. You have your choice of method. What method do you guys want to use? They're in standard form, but what method of solving? So, yeah, I'm going to use elimination also. Okay, so I'm looking for either my x or my y to be evenly divisible. In this case, they both are. Okay, so I can just pick one. Let's just pick x because it comes first. What number would I need to multiply by 1x to make it the opposite of 3x? Negative 3. Okay, so now you rewrite the equation. Negative 3x minus 6y equals negative 18. 3x plus 6y equals 18. Okay, so I just bring over the other one. Now I'm going to add everything together. So what I wanted to happen is I wanted my x's to cancel, and they do. But now what ends up happening to my y values? They also cancel. Okay, so this is 0. So if the other side is 0, then it's infinite solution. If it's any other number, it's no solution. What's negative 18 plus 18? 0. This is true, which means these equations, even though they are opposite in their signs, they're actually the same line.
It has infinite solutions if it's 0.
If 0 equals 0, if everything cancels. Okay? All right, I want you to look at the next one. I want you to try to figure out what you would multiply the top equation by. I also need you to change the bottom equation to 10, not 0. It should be 4x plus 2y equals 10. Okay, so go ahead and make that change and see if you can multiply your top equation by a value that would get either your x or your y to cancel. Okay, all right, what did you multiply the top equation by? Negative 2. So did you get negative 4x minus 2y equals negative 10? Okay, now bring over the other equation. All right, and you might even notice as you were writing that, what actually ends up happening?
All zeros equals 0.
They all cancel. 0 equals 0. So it is, again, infinite solutions. Okay? All right, let's do another practice one. And then we will kind of finish up. I think we have one more problem after this. What did you multiply the top equation by?
6.
Positive 6. And you get 12x minus 24y equals 60. Now, when you start bringing over the other equation, you should probably notice something, right? Everything cancels. 0 equals 0. So, if it's in a section where you're not really sure, so this is what it's going to look like on your quiz on Friday. Is the answer one solution, no solution, or infinite? One solution means I actually can solve this. No solution means same slope, okay? They never cross. Or infinite, it's the same line. So I want you to look at this system. All right, since we're only doing one, I want you to you think to yourself, what method would you choose? All right, maybe try to get through the first step or two. What would you guys do?
I
Hudson, what method do you think? I would do elimination also. Is that what you're going to say, Mikhail? Okay. Elimination, why? Yeah, the y's cancel. But what is 2x plus x? Is that going to cancel? No. 2x plus x is 3x. So right now, I know I have a solution. Because if I had a special solution, the x's would have canceled too, and they didn't. So 3x equals, what is 6 plus 3? 9. I can solve this.
I did not do it like that.
All right. X, do it with me. X equals 3. I can solve this just like I've been solving systems this whole time. This is not a special solution. This is one solution. I have part of my solution. How can I find the other part? What can I do? Talk to me. Plug it in. So I'm going to use the second equation, or you can use the first one, either one. 3 minus 1y, just put that 1 to remind you, equals 3. Subtract 3. Might even be able to have done this mental math from the beginning, but negative 1y equals 0. So y equals 0. Can't divide anything by 0. Okay, this is an answer. It is the right answer. 3, 0. Right, you got to put it together. You got to put it together. You can have 0 for a y value. Your x's and your y's did not cancel out. So you can have a value of 0 once you solve for y. This is one solution. All right, so you have to understand, if I can solve it, if I get an ordered pair, my answer is one solution.
What if it's 5 equals 5? Is that one solution?
All right, so that's going to be it for your last lesson of the chapter.